Good morning, everyone. Today, let us do Navy-based classifier. Basically, this is a classification algorithm. Navy-based classifier can be applied to all the learning problems again, where each instance X is described by a convention of attribute values. So, similar to the playTennis dataset, what we have seen earlier. Okay, so there we have multiple attribute values, right? So, if you take a conjunction of all that, instance X can be described. So, that is, suppose if for the playTennis we have for the outlook attribute sunny, forecast, and rain. So, these are the possible values, right? When I take a conjunction on all this, okay, so I should be able to define this instance. This is describing the instance X. So in a similar way, whatever learning tasks are there where you can express the instance X as a convention of attribute values, all that you can use maybe based classifier. And the target function f of x can take on any value from some finite set V. So that is the target of any learning problem, right? Taken any instance, you should be able to map that to the target function. If you, we already know the representation, always the instance should be mapping to some V. So taken a target function F, the instance X should map to the target value. So all these sorts of learning problems can be solved with the help of Navy-based classifier. So now, how to predict the target value? Predicting is nothing but classifying. So classifying a new instance based on the training examples. So that can be done for a given target function f extends to v. A set of training examples are already provided. Okay, so you are already training the classifier enough by these training examples, and whenever a new instance is given, this new instance is described once again by a tuple of attributes. Then the Navy-based classifier has to, the learner is asked to predict the target value or classification for this new instance. Okay, so this is what to be done. Already the training data will be done and the algorithm has to classify the new instance. Let us see one example. So like this, the training data will be given. So here if you see altogether D1 to D4, 14 training examples we have. And we have the classification also. That is the target value. S or no's are also there in this data set. Okay. So when the algorithm is running through all these examples, it will learn. Already it has the training examples. So based on these training examples, we suppose if a new instance is given. So here you can see we have taken a new instance. Outlook equals to sunny, temperature is equals to cool, humidity is equals to high, wind is equals to strong. These are the attribute values. Based on this, what can you conclude? Whether play tennis will be yes or no. What will be concluded by the algorithm? So that has to be done. So the same thing we have done in the ID3 also, in the decision tree using ID3 algorithm also done. Okay, but where the difference lies is here in the decision tree we have certain limitations, right? So we already discussed what are the issues with the decision tree. But here exactly I can tell with a numerical measure, with a probabilistic measure, I will be telling yes, this is the outcome for the particular instance. That we can do. So whereas that is not possible in the earlier algorithms. So here is the Navy-based algorithm in brief. Okay, so here always we will be computing the most probable value, okay, which can be expressed with the help of VMAP. VMAP is argmax of Vj belongs to V, P of Vj by A1, A2, so on, N. So these are the attribute values. So the same thing with the help of Bayes theorem, we can also represent it as P of A1, A2, N by Vj multiplied with P of Vj by P of A1, A2 so on up to an. Okay, so this is the basic Bayes theorem formulation, right? So now if you observe the denominator, so this is just the probability value, that is which is going to be some number. Okay, so with this number we will not be means in the classifier they will not be any much learning. So what we are doing is in the next step we are just ignoring this and we are taking only the numerator. We are focusing mainly on the numerator. Based on this, the classification values will differ a lot. So simply the Navy based classifier, we are expressing it as argmax Vj belongs to V, P of Vj. So you can see this term I have brought to the front. Okay, P of Vj and the product phi I P of Ai by Vj. So why we are taking this? So here from this term, if you see the probability values of all these arguments, we are assuming that they are independent events. So only we are taking the multiplication on these. So this is the assumption that we are taking in the Navy base. We are assuming that the events are independent. Their probabilities are not dependent on the other. So in the independent event system, simply we will multiply all the probabilities. So we are taking a pi here. So this pi stands for multiplication. So we were considering this Navy based classifier. Let us work out with one learning example. Let us take the same playTennis dataset and on that let us work out with this Navy based classifier. So in the Navy based classifier, in the previous slide if you observe, we are having two values. Okay, so here we have the P of Vj, which is the prior probability. So prior probability means a value which you already know. So this is not dependent on the happening of any other event. Okay. So we have the prior probabilities as well as we have the conditional probability also. So this is the conditional probability term. So where occurrence of AI, the probability of occurrence of AI, when we already know that Vj has happened. For example, suppose if we take an example of attending an exam. Okay, so you have an exam, then what is the probability of you attending the exam? Saying that you have some emergency at home, so what will be the probability? So the thing is you have an emergency but you have to attend the exam, you want to attend, so what is the probability of you attending the exam when you have some emergency at home? Whereas the prior probability we will be computing based on the data set which is given already. So let us work out with this with a numerical example. So the data set is the playTennis data set that we are assuming. Let us go back to the data set once. And here, if you observe, in order to calculate the prior probability, first of all, I should know how many positive instances are there, how many negative instances are there. So if total instances are 14, I have a total of 14. Out of this, positive instances are, how many S's are there? S are positive instances. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 positive instances are there. Negative instances are the ones with no. How many are there? 5 are there. So out of 14, 9 positive instances are there. 5 negative instances are there. So with this data, let us calculate the prior probability. So in the playTennis data set, the prior probability. So P of playTennis is equals to S. What is the probability? I already know that the target value is S. Okay, so total number of Total instances are 14. Out of this, how many S's I have? I have 9 positive instances. So this is my prior probability of playTennis is equals to yes. Similarly, with playTennis is equals to no. So how many negative instances are there? 5 negative instances are there with a total of 14. So this is how we will be calculating the prior probabilities. One second, let me give you the simplified values also. So if you simplify these values, 9 by 14 is giving you a value of 0.64 and 5 by 14 is giving you a value of 0. Okay. So this is how we compute the prior probability. So this is nothing but P of Vj. So where J is belonging to an S or no. So two alternatives we have. So we computed probability of the occurrence of the event with respect to S and probability of occurrence of event with respect to no. So both prior probabilities we computed. Now let us compute the conditional probabilities. So we have to calculate the conditional probabilities for all the attributes. Okay. So now if I compute for the attribute outlook, outlook has three outcomes: sunny, overcast, and rain. So now for these all outcomes, I have to compute the conditional probability against S and against no. So now once again, let us look back to the data set and see how many attributes of sunny you have with S. Okay. So here I already know how many positive instances are there. 9 are there. Okay. So in the conditional probability, so let me write the term. It is P of AI by Bj. It is. So AI is the current attribute. Bj is the outcome that I am taking. How many? So this Vj, just now I have written the Vj is either an S or no. So now I know how many positive instances are there. So total positive instances are 9. There is no change in the number of positive instances, but the number of events with sunny. So how many sunny are there with S is 2 are there. And how many negative examples are there altogether? 5 negative examples are there. Out of that, with sunny we have 3. Then similarly with overcast, I have 4 positive out of 9, and then there are 0 negative samples. Then in the rain, so rain positive 3, negative 2. Okay. So here only confusion that you will get is giving this number. So okay, number of positive instances and number of negative instances. Okay. So positive instances altogether are 9. Out of that, the number of attributes that have a value of sunny is 2. Sorry, here I have written wrong. It is 2, 2 by 9. And number of negative is 3 by 5. So let us just go back to the data set. I will just show for this one attribute and the remaining will just do it. So here you can see. So total SS are 9 we have, right? Positive instances are 9. So out of this, just let us look for sunny. Here I have sunny. Okay, so if you see its value, it is no. And here also I have sunny. Its value is yes. And then here I have sunny. Value is S. So far 2S. And here I have sunny. And here I have sunny. Both are no. So that means 3 positive instances are there and 2 negative instances are there. So only we are giving 3 by 5 and So all the time you should keep the data set beside and just see how many attributes are there with Sunny S and how many are there with no negative attribute. No. So similarly, let us do it for the other attribute as well. Let us take the temperature. So temperature has three attribute values: hot, mild, and cold. Okay, so out of that, under hot, the number of positive and negative instances we should take. Similarly for humidity and also for wind we need to do. Okay, so if you see the temperature, we have two positive instances and two negative instances. Similarly, for mild, we have four positive instances and two negative instances. Similarly, for cool, we have three positive instances and one negative. And then for humidity, humidity is taking two values, high and normal. Then with S, number of positives are 4 out of 9, and then negatives are 3. Number of positive instances with the normal are 6, negative are 1. Then for wind, two attribute values, weak and strong. With S, it is 6 by 9, it is 2 by 9, 2 by 5. Number of negative samples are 5. Next, with strong, positive is 3, negative is 3. Okay. So like this, we have to compute the conditional probabilities from the given table. Okay, so we have calculated. So far, this is the training data. So from the training data, we have calculated what is the prior probability and what is the conditional probability. So now keeping these in mind, we have to calculate for the new instance. So this is the new instance. So here the attribute values are outlook equals to sunny, temperature is cool, humidity is high, wind is strong. So now using the navy based classifier, we have to classify whether its target value is going to be an S or is it going to be a no. Let us do that. So value of the navy based classifier can be given as Argmax of Argmax B Bj belongs to S or no. Two values it is taking. The attribute, the possible target values. So possible target values are S and no 2. I'm just restating the formula again. P of Vj multiplied with pi of I ranging from Ai by Vj. So now we already have all the values, right? So now using these attributes, let us rewrite the formula again, which is R max P of, for S I should do once. Vj values are 2, right? For first let us do it for S. Okay, P of S. So the prior probability. So prior probability in case of playTennis is equals to S. And then next coming to the conditional probability. It is a multiplication of all. So let us just multiply this with P of, the first AI is outlook equals to sunny. Sunny given as multiplied with P of cool given as multiplied with P of humidity is equals to high Similarly, probability of strong event is. Okay. So far we have computed the value of navy pairs in case of yes. Okay. So similarly, we should calculate for no also. First, let us do the substitution and later on we solve for the value. So for the same thing, let us do for a VJ value no also. So that is P of probability of playTennis is equals to no multiplied with P of sunny in case of no, the conditional probability of cool in case of no, and then P of I case of no multiplied with P of no. So this is V and V of no. One second, let me change the pointer color. So actually, I just want to show you what is the meaning of this argmax. Okay. So here we are computing the probability values for the case of S as well as for no. Out of these two, whichever is maximum, that will be considered as the outcome. Okay. So only I'm doing both in the same. If you are not comfortable with this, you can do it separately also. So like this part. VNB of S you can do it separately and VNB of no also we can do separately. That I will show in the next problem. In this problem we will do it in a single stretch so that you will have an idea of the argmax. So this is VNB of no. Well, so 2 we have. So let us just substitute for the values of this is equals to argmax. From the table we have the values of all these, right? P of S is 0.64 that we computed, and then P of Sunny given S, it is 2 by 9, and then P of Cool given S, it is 3 by 9, then P of High given S is 4 by 9, and then P of Cool, sorry, P of Strong given S is 3 by 9. This we are taking these values from the conditional probability that we calculated earlier. I'll just go back one slide and I'll show you where from where I'm taking these values. So this value from these tables, I'm just taking the values. If you see this is P of Sunny in case of S. Okay, Sunny in case of S, P of Cool. So here I have written it as 4. Okay, so cold in case of S, it is 3 by 9, and then humidity high in case of S is 4 by 9, and then wind is strong in case of S, it is 3 by 9. I hope you got from where we need to take these values. This is the value. case of strong, it is 3 by 9. So all these values we have to multiply. So that is what we did it. So similarly, let us take the value for the other case also, and let us just substitute P of n is probability of no. So this is the prior probability, which is 0.36. And then P of Sunny given no is 3 by 5. Then 1 by 5. P of Cool given no is 1 by 5. P of High given no is 3 by 5. And P of Strong given no is also 3 by 5. So we need to simplify these values. Okay. So after simplifying, B and B value we are getting it as for S we got a value of 0.0067. In case of no, we got it as 0.0155. So now out of these two, so this is in case of the target value as this is the value for target value no. So now which is maximum? I got a maximum value for no. So from here I can classify that the new instance whatever we have taken, we can label its target value as no. Okay. So sometimes you need to normalize also. Okay. So let us see the normalization procedure also. The final. So for normalizing, ENV of S, and to normalize the formula is ENV of S divided by ENV of S plus no, which is 0.0067 divided by, if you sum up these two values, we are getting a value of 0.222. I'll just do it here, 0.0 added with 0.0157. So this is giving you a value of 0.033. So now if you simplify this, you are getting a value of 0.301. Similarly, VNB of no also can be done. So this time there will be only change in the numerator. VNB of no is divided by VNB of S plus no. That is VNB of S plus VNB of no, which is 0.0155 divided by 0.0208, which is giving us a value of 0.6981. So now these are the normalized values. So here you are getting a value of 0.6 and here you have the value of 0.3. So from here also you can see that VNB of no value is greater. No is greater than VNB of. So So hence we can classify the new instance as no. The target value assigned for the new instance is no. So now playTennis. PlayTennis for the new instance is given as. So that means if these are the given constraints, then a person cannot play tennis. And here one thing you can verify, without normalizing also I got the same conclusion. So here you can see we got higher value for no case only. And after normalizing also we got the same. So you can cross verify here also that you are doing it in a right way. So you can verify your answer here. So with this, I'm concluding the Navy pairs classifier. So this is how the classifier is going to classify your new instance. So for your practice, you can just randomly take one more new instance and practice with that. Hope you all followed. If you have any queries, you can just post in the chat box.